have to integrate the function sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x. Let's begin with the solution. And let I is equal to integral of sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x into dx. Now we know that sin inverse theta plus cos inverse theta is equal to pi by 2. Therefore, I can further be written as integral of here sin inverse root x minus cos inverse root x as it is. And in the denominator we get pi by 2, since this is equal to pi by 2 into dx. This is further equal to 2 upon pi integral of sin inverse of root x can be written as pi by 2 minus cos inverse of root x. Then we have minus cos inverse of root x into dx. This is further equal to 2 upon pi integral pi by 2 into dx minus 2 upon pi integral. We have 2 times of cos inverse root x into dx. So taking the constant outside the integral, here we have integral 1 into dx minus 4 upon pi integral cos inverse of root x into dx. And this is equal to integral 1 into dx minus 4 upon pi. Let us denote this integral by I1. Now we have to find the value of I1, which is integral of cos inverse of root x into dx. Now let us suppose that root x is equal to t, that is x raised to the power half is equal to t. So on differentiating both sides with respect to x, we have half into x raised to the power minus half is equal to dt upon dx. That is dx is equal to 2 into dt, and here divided by root x, and root x is nothing but t. So this implies that dx is equal to 2t into dt. Therefore, integral I1 can be written as integral of cos inverse t into dx is 2t into dt. So this is equal to, taking 2 outside, integral of cos inverse t into dt. Now here we have to find the integral of the product of two functions, and we know ILATE. That is, if we have to find the integral of the product of two functions, the first function is the inverse trigonometric function, and here the second function is the algebraic function. So this is equal to 2 times first function into integral of second function minus integral the derivative of first function into the integral of second function into dt. This is further equal to 2 times of cos inverse t into integral of t with respect to t is t square upon 2 minus integral derivative of cos inverse t is minus 1 upon square root of 1 minus t square, and integral of t with respect to t is t square upon 2 into dt plus the constant c1. So this is equal to cos inverse t into t square. Now minus into minus is plus, and 2 into taking 1 upon 2 outside, we get 1. So we have integral of t square upon square root of 1 minus t square into dt plus 2 times of c1. This is further equal to t square into cos inverse t. Now this plus can be written as minus of minus t square divided by square root of 1 minus t square into dt plus 2 times the constant, and here adding and subtracting 1 in the numerator. This can further be written as t square into cos inverse t minus integral of 1 minus t square divided by square root of 1 minus t square into dt. Now here we get minus into minus is plus integral of dt upon square root of 1 minus t square plus 2 times of constant. This is further equal to t square into cos inverse t minus integral of square root of 1 minus t square into dt plus integral of dt upon square root of 1 minus t square plus 2 times the constant, and this is further equal to t square into cos inverse t minus, now integral of a square minus t square into dt is equal to half of t square root of a square minus t square. Here a is 1, so we have 1 minus t square plus a square upon 2. Here a is 1, so we have 1 upon 2 into sine inverse of t upon a. So we have t upon 1 plus the constant c2 plus integral of dt upon square root of 1 minus t square is sine inverse t plus, on integrating this, let c3 be the constant, plus 2 times of c1. So this is equal to t square cos inverse t minus half t square root of 1 minus t square minus half sine inverse t, now minus into plus is minus sine inverse t plus the constant c, which we get on adding these three constants. So this is the value of integral I1, and integral I is equal to integral 1 into dx minus 4 upon pi into I1. So we have integral I equal to integral of 1 into dx minus 4 upon pi into integral I1. Now let us substitute the value of I1. First, on integrating 1 with respect to x, we get x minus 4 upon pi. This is integral I1. So replacing t by root over x, which we have supposed in the beginning. So here we have root x whole square. That gives x into cos inverse root x minus root x divided by 2 into square root of 1 minus t square, that is x, minus half to sine inverse root x minus sine inverse root x plus the constant. This is further equal to x minus 4 upon pi. Now here x into cos inverse root x can be written as pi by 2 minus sine inverse root x minus root over x minus x square upon 2, and simplifying these two we get minus 3 upon 2 sine inverse root x plus the constant d So this is equal to x minus 4 x upon pi into pi upon 2. Now minus minus is plus. So we have 4x upon pi sin inverse root x. Then we have minus into minus is plus. 4 upon pi into square root of x minus x square divided by 2. Again minus into minus is plus. 3 upon 2 into 4 upon pi sin inverse of root x plus the constant d. So this is equal to x minus, on simplifying this, we get minus 2x plus, taking sin inverse common from these two terms, we have 4 upon pi into x plus 3 upon 2 into 4 upon pi sin inverse of root x, and on simplifying this we get 2 upon pi into square root of x minus x square plus the constant d. This is further equal to minus x plus, taking pi common we have 4x plus 6. So taking 2 common we have 2x plus 3 into sin inverse root x plus 2 upon pi into square root of x minus x square plus the constant. Therefore, on integrating, sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x into dx is equal to minus x plus 2 into 2x plus 3 divided by pi into sin inverse root x plus 2 upon pi square root of x minus x square plus the constant d. This completes the solution.